Hello everyone and welcome to this video. In this video we are going to be looking at last regression model evaluation metric today. Okay, so if you haven't watched the previous videos or you'd just like to catch up with what we've been doing so far, please consider watching the previous videos and then you'll have a basic idea of what we're trying to do. And then so let's start this video. Today we're going to be looking at mean squared error. That's the evaluation metric we're going to be looking at today. And if you are caught up with my previous videos, or you already know what mean absolute error is, then you'd probably already know what mean squared error does. So let's actually see this in action. So let's just put a comment down here, and our comment is just going to say, our comment will just be saying mean squared error. It can also be known as MSE, but I doubt you'd be seeing that around. And then after that, if we need to import mean squared error, it's a function, so we need to import it. So from Scikit-Learn.metrics, import mean squared error. Okay. And also make sure you put in your underscores, otherwise it's going to throw you a nasty syntax error, and you do not want that because you may or may not have any idea why you got that wrong until you just look at what you've written. So make sure you do that, and then now we can see it in action, or maybe the result. So MSE, or mean squared error, is equal to mean squared error. You can press tab to autocomplete. I just did that. And then you're just gonna go ytest, ypred. So we've already created these. If you want to go ahead and create these, look at the previous two videos where we did that, and maybe you will have created them already. And then what we're just going to do is we're going to view MSE, and what we get as our result is 9.867, etc., etc. Okay? So we want to know, how did it calculate this result, and what does this all mean? So if you what we're going to do is we're going to calculate MSE by hand, and then that will let us understand what it does. So I'm just gonna we're gonna calculate this using NumPy or NumPy, however you want to say it. We're gonna calculate it using NumPy, the library. So make sure you have that imported. So we're gonna go squared is equal to np.square. So thankfully it already has that function method built in. And then we put df, and then our df is basically a data frame that we created in the previous video. So make sure you've created that data frame already. And there's also this column called differences in that data frame, and that is the one we're going to be squaring. So we're going to be squaring all the values in there, and then we're just gonna say squared dot mean, and that will be MSE calculated by hand. So there we go, we have exactly the same thing there. So if you thought about it, or if you've already cracked what this does, mean squared error basically is mean absolute error, but what it does is it squares the differences, and then it gets the mean of those differences again. Okay, So, you may be wondering, why on earth would I need to square the differences to evaluate a machine learning model? So that's what I'm going to show you right now. So here is my slide, and it said, which regression model evaluation metric do I use? So here are the 3 regression model evaluation metrics that we have covered so far. So the first one that we covered is R2 squared, or just R squared, not R2 squared, it's R squared. It's a simple evaluation metric you can use. So this is probably the most simplest out of the 3 that we have learnt. So it's probably the most simplest, and just make sure you don't use it too much because it's not that very informative. It's not very informative. It only gives you the proportion of the correct predictions. So it only tells you how many are correct, how many predictions were correct. So that's not really helpful in terms of evaluation, because it will only give you how many were correct, and it won't give you any more information for improving. So if you want more information for improving, best not to use R squared, although it is a pretty good one evaluation metric to use. But if you want to be a bit more informative, what you need to do is you might as well use mean absolute error or mean squared error. So mean absolute error, it's really helpful as it informs you how close the model's predictions are on average. So when it's on average, it's much easier than having to calculate all the values by hand. It just does it for you, and it gives you the average. So you might be thinking the average isn't that good because there might be some ups and downs. So it is actually really good, because even if you do have anything left that is a bit wrong and you're trying to improve it, then you'll be able to do that with the average. And this doesn't always help. It's not always effective depending on what sort of problem or data set you have. So it can help a lot when differences are small, but it's not as effective if the differences are quite large, or if the problem is really large. So basically differences. So this is where we can use mean squared error. So mean squared error wasn't that effective in this video because our differences were not that big. But when your differences are really big, you can use mean squared error to amplify the differences, and it will allow you to pick out the big problems in there and try to solve them. So it can help deal with your model's problems easily and efficiently. Just don't use it too much on the small differences because it's not going to be that effective. So just make sure you use it on the small differences. Alright, so that is basically the end of this video. That's all I want to tell you today. If you have learned something new or you just like this video, please like and consider subscribing as well. It's free and you can always unsubscribe. If you have any doubts, please comment them in the comment section below, and I'll be happy to try my best and answer them. So I guess that is the end of this video. So yeah, have a nice day and bye.